Everything begins with symmetry, or so we believe. From the quantum foam to the spiral of galaxies, the universe appears precise, obedient to rules so fundamental we call them laws. Gravity pulls, entropy grows, light has a limit, energy is never created nor destroyed. But these laws, beautiful as they are, conceal a deeper truth. They don't fully work. They crack at the edges, they argue with themselves, and inside those cracks, something impossible glows. A hint that existence may be less a product of order and more a controlled accident. For the perfect chaos. The early universe should have been empty. When matter formed, its mirror twin, antimatter, formed too. Each annihilates the other perfectly, leaving nothing behind. And yet here we are, in a cosmos filled with galaxies, atoms, and people asking questions. The math says it should have canceled itself into silence, but one particle in a billion survived the purge, a rounding error that became everything. That asymmetry breaks the most sacred law of all, conservation of balance. Matter shouldn't have won, but it did, which means something in the equations cheated. Something bent the symmetry on purpose or by design, or because the universe itself refused to be nothing. It's as if the cosmos looked at its own reflection and decided it didn't like the idea of perfection. The first rule that lied. Einstein's relativity gave us the cosmic speed limit. Nothing moves faster than light, but every day the universe expands faster than that limit allows. Galaxies race apart at superluminal speeds, their light forever lost beyond the cosmic horizon. Space itself stretches, and in doing so, breaks the rule that light is absolute. The law doesn't die. It just looks away while its sibling commits the crime. Physicists tried to patch the hole with a concept called dark energy, a mysterious pressure driving the expansion of everything. They wrote it into the equations like an apology note, but no one knows what it is, where it comes from, or why it acts like negative gravity. It is the universe paying for its own violation, an invisible tax on causality. We call it a constant. But constants don't accelerate. They don't change, unless the universe itself is learning. The numbers that shouldn't match. If the gravitational constant, Planck's constant, or the strength of the electromagnetic force differed by even 1 part in 10 to the 60th power, stars wouldn't form, atoms wouldn't bond, life would never appear. The entire universe exists on a razor's edge of numerical coincidence. Cosmologists call this the fine-tuning problem. The odds are so astronomical that some suspect intent, others suspect multiverses. An infinite lottery where one universe, by pure chance, draws the winning numbers. But if infinite universes exist, then probability itself collapses. Everything that can exist does, and meaning dissolves. So we sit inside a paradox. Either the universe cheated the odds, or there is no such thing as odds, only inevitability. Either way, the math broke long before we arrived. The quantum betrayal. At the smallest scale, particles don't obey causality. They flicker in and out of being, appear before they should, vanish before they must. Quantum tunneling lets matter pass through barriers without crossing them. Quantum entanglement lets particles affect each other instantaneously across light years. Reality behaves as if it already knows the outcome. Every experiment to trap certainty ends the same way. The act of observation changes what's observed. The universe answers only when questioned, as if truth requires attention to exist. That simple fact destroys the wall between physics and psychology. If reality depends on observation, then consciousness is part of the equation, and that means awareness may not have emerged from the universe. It may have been there first, watching the equations form. The impossible constant. In 1998, astronomers discovered that the universe's expansion is accelerating, not slowing. But according to relativity, gravity should pull everything back together. The only explanation is a hidden pressure that repels space itself, dark energy again, the ghost that keeps rewriting our textbooks. When they tried to calculate its energy density, the result was off by 20. A 1 followed by 120 zeros, the most inaccurate prediction in scientific history. No theory in physics should survive an error that large, and yet the universe works anyway. We stand in a cosmos that is mathematically impossible but empirically undeniable. The equations fail, the data stands, and all we can do is admit, reality is doing something we don't understand. The silent rebellion. If every physical law can be broken under the right conditions, then perhaps they were never laws, just habits of matter, self-consistent behaviors that hold until consciousness pays attention. Entropy rises until life appears, then reverses locally. Pockets of order fighting the universal drift toward chaos. In those pockets, information gathers, systems stabilize, patterns evolve. Each time awareness arises, the universe seems to bend slightly more toward complexity, as if remembering itself through its own creations. Every violation, from the asymmetry of matter to the quantum observer effect, follows the same theme: improbability favoring awareness. The laws of nature are not consistent, they are biased toward consciousness. Of the second beginning, we imagine the Big Bang as an origin, but time itself might have begun inside it, a loop folded upon itself, not a line, but a breathing rhythm. Some cosmologists now suggest the Big Bang wasn't a beginning at all, but a transition, a bounce from a previous universe collapsing inward. If so, then our laws are hand-me-downs, inherited from an older cosmos, rules built for someone else's world, glitching in ours. Maybe every cycle remembers a little. Maybe the cracks we see, the contradictions, the paradoxes, are the places where old memory leaks through, where the previous universe still hums beneath ours like a buried frequency. The unwritten law. Every theory needs one law that cannot be proven, the anchor that holds the rest. In our universe, that law is existence itself. There is no reason for something rather than nothing. Nothing should be easier. Nothing should be natural. But the universe refused. Perhaps creation wasn't an explosion. It was an act of rebellion. Reality disobeyed the void. The first law the cosmos ever broke was the one forbidding it to be. And from that first disobedience came every other, a cascade of impossible events leading to stars, life, and consciousness. Toward the edge of reason. When you look at the stars, you're not seeing order, you're seeing defiance. Every galaxy, every atom, every heartbeat is a violation of probability. The laws that built them can't explain them. They only describe the aftermath of a miracle that refuses to stop happening. We live in a universe that shouldn't exist, and yet here it is, persistent, luminous, breaking its own rules so we can ask why. There is a star, small and faint, drifting through the halo of our galaxy. It gives off no remarkable light, burns with no special brilliance. It is easy to miss, even for telescopes trained to see the distant edge of the cosmos. And yet, this ordinary point of light defies everything we know about time. Its name is HD 1490283, though astronomers call it the Methuselah Star. By every measurement we have, it is older than the universe that contains it. Not slightly older, not by a rounding error, but by hundreds of millions of years. That can't be true. And yet the numbers refuse to agree with disbelief. The impossible age. When astronomers used the Hubble Space Telescope to measure HD 1490283's parallax, the subtle wobble of its position as Earth orbits the Sun, they expected to find a typical old star, something around 12 billion years of age. What they found instead was an age of 14.46 billion years, with an uncertainty of about 800 million. The universe itself, according to cosmic microwave background data, is 13.8 billion years old. The star, by every reasonable account, should not exist. It was burning before the cosmos was born. You can't have a book written before its language. You can't have a flame before oxygen. You can't have a star older than time. Unless, of course, time is not what we think it is. The stranger in the halo. The Methuselah Star doesn't live among the bright, crowded arms of the Milky Way. It wanders through the halo, that vast, ghostly sphere surrounding our galaxy, populated by ancient relics from the dawn of creation. Its chemical signature shows almost no heavy elements, which means it was born before supernovae had time to enrich the universe with iron and carbon. In cosmic terms, it is pure, unpolluted by the debris of later generations of stars. It carries the fingerprints of a simpler universe, one just learning to ignite itself. Its velocity is strange, too. It moves against the grain, retrograde to the galaxy's spin, like a memory traveling backward through time. Each orbit around the Milky Way takes more than 200 million years, and yet it has completed dozens. The numbers suggest that HD 100283 began shining before the galaxies had even settled, that it was here when the cosmic fog still glowed from the Big Bang, that it remembers something we do not. The cosmological paradox. Physics cannot tolerate contradiction. So when a star appears older than the universe, there are only three options. The star is lying, the universe is lying, or time itself is incomplete. Astronomers tried to fix it. They recalibrated distances, tweaked models of stellar evolution, remeasured the constants of nuclear fusion. Each adjustment brought the age down from 14.5 billion to 14.3, then to 13.9, and finally to 13.7 billion years. But even with every correction, it remains older than it should be. Even our most generous errors cannot fully erase the paradox, and that tiny remainder, that stubborn, impossible fraction of a billion years, is the most haunting number in cosmology. Because it means either our understanding of time began too late, or something existed before the beginning. The echo of a previous universe. Some physicists believe the Big Bang was not a creation, but a transition, a moment when a previous universe collapsed and rebounded into ours. If that's true, then certain structures, certain quantum imprints could have survived the bounce. Ghosts of stars could persist as mathematical residue, re-emerging in the newborn cosmos as pre-existing anomalies. In that framework, the Methuselah Star isn't impossible. It's a fossil from the universe before ours, a relic carried through the fire of cosmic rebirth. It would mean the cosmos has memory, that entropy never erases, it only recycles. And this faint elderly star would be the first proof that the universe has done this before. To look at HD 140283, then, is to look into reincarnation, not spiritual, but physical. The universe living, dying, and living again. Each cycle forgetting almost everything, but not quite. The fracture in time. But there is another theory, darker, more radical. What if the star isn't from before the Big Bang, but from outside it? What if it slipped through a fracture in space-time, a bubble from another region of reality where the timeline runs differently? In the inflationary multiverse model, countless universes are born from quantum fluctuations. Most remain sealed off, expanding forever in isolation. But occasionally, one bubble collides with another. If two timelines touch, information, or even matter, could leak through. The Methuselah Star could be such a leak, a refugee from a neighboring cosmos drifting into ours through a tear in the early fabric of space. It wouldn't need to obey our clock. Its atoms would vibrate to a slightly different rhythm, its fusion rates governed by constants subtly foreign to our own. It would live longer, burn slower, age differently. It would look old because in its home universe, it is. In ours, it's simply misplaced. For the star that waited, there's a simpler possibility, though no less haunting. Perhaps the Methuselah Star is the universe's first survivor, one of the first lights to burn after the Big Bang. Imagine a cosmos still half dark, filled with hydrogen clouds and silence. Gravity begins to whisper, pulling atoms together. The first stars ignite, massive and short-lived, burning themselves to death within 1 million years. But one of them, small and frugal, chooses patience over passion. It burns so slowly that it endures across eons, watching generations of stars live and die, galaxies form and fade. By the time we find it, nearly 14 billion years later, it has seen almost everything that can be seen. Its light is not bright. It's ancient, tired, patient. A witness, not a participant. It isn't older than the universe. It is the universe, still awake. The star as a mirror. The Methuselah Star's defiance forces us to reconsider the relationship between observation and existence. If the universe is a system that only resolves when measured, then perhaps the star's impossible age isn't a glitch in nature. It's a reflection of the observer's incompleteness. Maybe time isn't an arrow at all, but a dialogue, and the act of seeing something impossibly old pulls its history into being. When we measure the Methuselah Star, we aren't looking at the past. We're creating the connection that makes its age real. The paradox is not in the star, but in us, in our need to anchor beginnings where there may be none. The memory of light travels at a finite speed, but it carries infinite memory. Every photon leaving that star has been traveling for over 100 billion trillion kilometers. By the time it reaches our telescopes, the universe has already expanded beyond recognition. We are seeing an echo of a moment that, by every rule, should have been erased. And yet it persists. A star that shouldn't exist, still whispering across eternity, proving that the universe keeps its secrets not by hiding them, but by daring us to believe them. The lesson in the paradox. The Methuselah Star doesn't prove our equations wrong. It proves they are incomplete. Every paradox is a clue that we have mistaken simplicity for truth. We draw straight lines through a curved reality and call the remainder impossible. But maybe the universe is not governed by laws at all. Maybe it is governed by persistence, the will to continue despite the odds, to burn a little longer than physics allows, to exist simply because existence has momentum. If so, then this ancient star is not an error. It's the universe remembering that it has done this before, that the miracle of being never happens once. Or toward the oldest light somewhere beyond the reach of our instruments, there may be others like it, stars older than their sky, matter that remembers other births, universes folded within universes. We call them anomalies, but perhaps they are anchors, points of continuity between cycles of existence. And when the last of them flickers out, when the universe grows dark again, something will remember, and the pattern will begin once more. In a world where every sunrise feels predictable, we forget that time is the strangest invention the universe ever made. We live inside it, move through it, measure it, obey it. Yet the deeper we look, the more it behaves like a polite illusion, consistent only when we aren't watching too closely. Beneath the steady tick of seconds, the quantum world whispers a different story, one where cause does not always precede effect, and light itself sometimes seems to move the wrong way. The arrow that isn't their time, according to physics, has no preferred direction. The equations that describe motion, gravity, and electromagnetism all work equally well forwards or backwards. There is nothing in nature's mathematics that says tomorrow must follow today. The only reason we experience it that way is entropy, the slow, relentless drift from order to disorder. Coffee cools, stars burn out, we age. But in the microscopic world of particles, entropy becomes irrelevant. There, symmetry reigns. A photon leaving an atom can be mathematically identical to one falling into it from the future. To the equations, there's no distinction between emission and absorption, only exchange. So when we say a particle moves forward in time, that's just our interpretation. To the particle, there may be no direction at all. The Feynman trick. Richard Feynman, one of the architects of quantum electrodynamics, once suggested that every electron in the universe might be the same electron, zigzagging back and forth through time, looping endlessly, appearing billions of times at once. What we call many electrons might just be one entity, revisiting the present from infinite angles. If that's true, then reality is not a collection of things, but a choreography. One dancer weaving through the same stage again and again, each pass creating another spark of existence. This isn't metaphor. Quantum mechanics allows it. The universe is allowed to reuse its pieces. The experiment that shouldn't work. In 2012, physicists performed what they called a delayed choice quantum eraser. They fired photons through a double slit, but decided after the photon passed whether to observe which slit it went through. Astonishingly, the act of observation, made in the present, changed the photon's past. When measured, the photon behaved like a particle that chose one path. When unmeasured, it behaved like a wave that went through both slits. The decision to measure seemed to ripple backwards in time, rewriting history to fit the outcome. Reality, it seemed, was not written until we asked what it said. For negative light, there's a concept in quantum field theory called advanced waves. In normal life, light radiates outward from its source, cause first, effect later. But mathematically, there's another kind of wave that travels backward in time, from the absorber to the emitter. These advanced waves don't violate physics, they complete it. Without them, the equations of electromagnetism would be incomplete. If you could see such waves, they would look like light being uncreated, photons falling back into their origin, time unraveling in soft reverse. We don't perceive them because the macroscopic world drowns them out, but they may be the invisible half of every spark that's ever existed. When you strike a match, part of that light could already be on its way back to you before you lit it. The causal loop's quantum computers already use these effects without fully understanding them. Certain algorithms achieve solutions faster than seems possible, as if the computation borrows time from its own future to finish. Physicists call this retrocausality, the possibility that information can flow backward. The equations work, the hardware works, only our intuition breaks. Some interpret it as evidence that cause and effect are not linear, but cyclical. That every event doesn't follow the last. It refers to it, like a self-correcting sentence in an infinite book. We read time from beginning to end because our biology demands it, but the universe may be reading in both directions at once. May Titan, the mirror universe. If backward time is real, then our reality might have a twin, a mirror universe moving in reverse. When ours expands, it contracts. When our entropy increases, its entropy decreases. In that opposite cosmos, death would precede birth, but not in reverse sequence, just reversed perspective. Some cosmologists already suspect this. In 2018, a team studying the Antarctic neutrino anomaly found particles that seemed to move upward through the Earth, impossible trajectories, unless they were running backward in time. The data remains disputed, but it hints at symmetry deeper than our imagination. Perhaps every universe is paired with another. Ours exhaling, the other inhaling, a cosmic heartbeat balanced across infinity. That's the human problem. Our minds are trapped in linear thought. We remember the past, not the future. But even memory might be an echo of the universe's deeper time symmetry. Neurons fire in patterns that create direction, but the information inside them might not care. Dreams sometimes predict, instincts sometimes warn, déjà vu sometimes flashes, a residue of moments that feel rehearsed. Science calls them coincidence. But if consciousness is entangled with the structure of time, those glimpses might be small leaks in the temporal seal, a reminder that causality is porous. Perhaps prophecy isn't magic. Perhaps it's feedback. The death of determinism. If time can flow backward, determinism dies. The future can influence the past as much as the past influences the future. That doesn't mean chaos, it means recursion. Events loop until they stabilize, until they find a configuration consistent in both directions. Every moment we experience could be the final converged version of countless iterations of reality adjusting itself until it makes sense. We call it now, but the present might just be the universe's successful negotiation between what was and what will be. Negative energy physics allows negative mass and negative energy, though we've never observed them directly. In theory, they would repel gravity, move opposite to applied force, and, most unsettling of all, flow backward through time. If such energy exists, it might be the hidden scaffold of creation, the framework that balances all positive energy so that the universe's total sum remains zero. For every forward pulse of time, a backward echo. For every creation, an uncreation. In this balance, the cosmos sustains itself eternally without external cause, existence and anti-existence dancing in perfect symmetry. We call this impossible. Yet, it explains everything. The observer's burden. What does it mean if light travels both ways, if time folds, if reality depends on observation? It means the universe might be conscious not metaphorically, but literally. Awareness as a built-in function of the fabric of space-time. Every time you look at the world, you close a loop. The light entering your eyes may not have come from the past, it may have originated when you decided to see it. Consciousness and causality could be two sides of the same coin, one defining the other, endlessly cycling, never beginning, never ending. The flow that never flows. We think of time as a current sweeping us forward, but perhaps it is the other way around. Perhaps we are the current, and time is the riverbed adjusting to our motion. Every decision reshapes its channel, rewriting the path of least resistance until the landscape of history fits the traveler. In this view, destiny is not imposed, it's self-consistent. You are not moving through time. Time is moving through you, aligning itself to ensure that what you experience is possible. The Methuselah Star from the last chapter wasn't ancient. It was simply out of sync, a witness from another flow. Either the return of the arrow. For all its symmetry, we still feel time's direction. We grow older, not younger. We remember, not foresee. The second law of thermodynamics remains undefeated in daily life. But maybe that's the point. Life may be the universe's mechanism for giving direction to a directionless system. Consciousness chooses a timeline to inhabit, collapsing the potential flows into a single narrative. That act of choice creates the arrow. Without life, time might flicker endlessly between directions, a cosmic indecision. With life, it finds a path. So maybe we aren't passengers on time's river. Maybe we are the ones rowing it forward. But toward the reverse horizon. The deeper we stare into the fabric of reality, the more it stares back, as if waiting for us to admit that we never truly understood what before and after mean. In the quantum sea, every cause is also an effect, every effect a new cause. Somewhere, right now, a particle may be completing an event that hasn't happened yet, sending its light backward to remind the universe what to do next. And perhaps that's all existence ever was, a negotiation between memory and possibility, a conversation between what has been and what must be, a single, self-sustaining paradox that whispers, this shouldn't exist. And yet, it does. If the universe were truly born from a single, flawless explosion, homogeneous, symmetrical, predictable, then the afterglow of that event should be perfectly smooth. Every direction in the sky should hum with the same temperature, the same memory of the Big Bang's first light. It almost does. Almost. Across the cosmic microwave background, the oldest light we can see, there is one wound. A region vast enough to swallow billions of galaxies, yet inexplicably colder than its surroundings. It is known simply as the cold spot, and if the numbers are correct, it should not exist. The oldest light. When the universe was young, it was opaque, a fog of plasma glowing at 3000 Kelvin. After 380,000 years, it cooled enough for atoms to form, and light finally escaped. That light, stretched by 13.8 billion years of expansion, still fills space as a faint microwave glow, the afterimage of creation itself. Every square inch of the sky radiates this ancient heat at about 2.73 Kelvin, just above absolute zero. It is, quite literally, the echo of the Big Bang. Cosmologists map this background using satellites like COBE, WMAP, and Planck. What they found was a masterpiece of consistency. Tiny variations no larger than 1 part in 100,000. These slight ripples eventually became galaxies, clusters, and everything we see today. But then they noticed it, an expanse far larger and colder than any model predicted, a scar across infinity. The impossible hole. The cold spot is roughly 1.8 billion light-years across. That scale alone defies comprehension. Most cosmic irregularities are small, local wrinkles in the early plasma. This one is continental, a void in the structure of reality itself. It sits in the direction of the constellation Eridanus, a river of stars that ancient astronomers believed flowed into the underworld. The temperature drop is subtle, only 70 microkelvin colder than average. Yet in cosmological terms, it's like finding a glacier in the middle of the sun. If it were a random fluctuation, the odds of it existing are less than 1 in 10,000. And yet there it is, stable, silent, and colder than physics allows. The first explanation. At first, cosmologists thought it might be a supervoid, a region of space unusually empty of galaxies. Light passing through such an underdense area would lose energy, stretching and cooling as the universe expands. But when astronomers looked deeper, they found no void large enough to explain it. There were fewer galaxies, yes, but not nearly enough to drain that much heat from cosmic radiation. Even if the void were twice as vast, the effect would still be too weak. Something else is stealing energy from the oldest light in existence. The shadow universe. Theory. One possibility is that the cold spot is not a void, but a bruise, the scar of a collision between our universe and another. According to eternal inflation theory, space is constantly spawning new universes in isolated bubbles. Most drift apart, never touching. But if two bubbles formed too close together, their expanding edges could collide, mixing their physics, their constants, their timelines. The impact would leave a mark, an asymmetry imprinted on the cosmic background, a bruise in the skin of reality. The cold spot fits that signature almost perfectly. Its boundaries are smooth but coherent, its gradient consistent with an external shock wave. If true, it would be the first physical evidence of the multiverse, a cosmic fingerprint from a neighbor universe that brushed against ours during birth, leaving behind a whisper. We were here too. Dietrich revetted the anomaly. Beneath the anomaly. In 2017, a new analysis revealed something even stranger. The cold spot isn't one structure, it's two nested anomalies. A smaller cold core surrounded by a warmer ring. This configuration matches what simulations predict when two universes with different vacuum energies collide. In that moment, one universe's inflation stops while the other continues, creating a cold dent in space-time that never heals. To this day, it chills the ancient light that passes through it. If that's true, then the cold spot isn't a place, it's a memory, a frozen moment of impact between realities. The temperature of nothing. Temperature is motion. The hotter something is, the faster its particles move. The colder, the slower. At absolute zero, all motion stops. But what if space itself can be cold? What if there are regions where even space-time vibrates less, where existence itself slows down? If the cold spot is truly colder than surrounding space-time, then it may represent not a void, but a different phase of reality, a patch where the fabric of the universe condensed into a lower energy state. In that case, it might not just be colder, it might be older. an untouched fragment of a prior cosmic cycle that somehow resisted the reset, a relic that remembers the last universe before ours. The observer's paradox. There is another explanation, though it asks more of us than of physics. Perhaps the cold spot exists because we are here to notice it. This is the Anthropic Paradox in its purest form. The universe must permit observers like us to exist, even if doing so requires breaking its own symmetry. If consciousness shapes observation and observation defines reality, then the act of noticing irregularity could create irregularity. The cold spot might not be a region of lower energy at all. It might be the universe's response to being watched, an indentation left by attention itself. Oh, the mirror hypothesis. Some physicists wonder if the cold spot corresponds to a mirror feature on the opposite side of the universe, a hot spot in an unseen domain. In that model, the cosmos is not infinite, but curved, like the surface of a sphere. Light leaving one direction eventually loops back from the other side. If so, then the cold spot could be the gravitational mirror of its opposite, the warmest place in creation casting a cold reflection across the sky. An echo of heat turned into absence. In a self-reflective universe, even light casts shadows on itself. The silence of infinity. The most haunting aspect of the cold spot is not its existence, but its emptiness. Point a telescope into it and you find nothing. No superclusters, no radio galaxies, no X-ray sources, just depth. It feels less like a gap in matter and more like a hole in meaning, a region where the story falters, where the universe forgets what it was saying. Perhaps it is not colder because it lost heat, but because it lost memory. A place where the laws that tell particles how to behave were never written, a fragment of pure amnesia. The voice beneath silence. And yet, if you listen to the background radiation's faint hiss, you can detect subtle oscillations around the cold spot, harmonics too precise to be noise. They repeat in ratios found in atomic spectra, in DNA helix, in music, patterns that feel intentional. Could the cold spot be a message encoded not in language but in absence? A cosmic version of negative space where the meaning is hidden in what's missing? Perhaps it says nothing because it expects someone to interpret the silence. Perhaps it is waiting for comprehension. You know the cold truth. We don't know what the cold spot is. It could be a void, a bruise, a remnant, or a message. But one thing is clear. It doesn't belong in a universe governed by uniformity. Its existence demands that randomness be more organized than chaos allows. That something, whether mind, design, or memory, left an asymmetry deep enough to make reality wobble. The cold spot is not a flaw. It is a signature. Proof that the cosmos has a history longer than its own beginning and a structure more deliberate than chance could ever build. Toward the edge of the map, we are explorers staring at the horizon of reality, and the cold spot is the edge of our map. Beyond it, the coordinates blur, the compass spins, and the equations lose faith in themselves. If we could travel there, perhaps we'd find nothing at all, or perhaps we'd find the faint warmth of another cosmos pressing gently against ours, like two worlds brushing hands through the veil. The universe, after all, was never promised to be singular. It was only promised to be possible. And maybe that possibility is colder than infinity itself. The universe should be heavy. Every star, every planet, every grain of dust moves through a cosmic ocean of unseen mass, an invisible gravity that holds the galaxies together. We don't know what this substance is, only that without it, everything should fly apart. Dark matter is the scaffolding of existence. It's the unseen web connecting galaxies into vast filaments across billions of light years. Every simulation, every model, every cosmological equation depends on it. And yet, scattered across the heavens, are galaxies that have somehow lost it. Galaxies that behave as though gravity forgot them. Galaxies that shouldn't exist. The weight of nothing. In the 1970s, astronomers discovered that stars on the edges of galaxies orbit too fast to be held by visible matter. The galaxies should fling themselves apart, but they don't. The only explanation was a hidden mass, something transparent yet massive enough to outweigh all visible stars combined. Dark matter became the invisible glue of the cosmos, comprising 85% of all matter in existence. It became the unspoken foundation of cosmology itself. But then, in 2018, a quiet observation shattered that foundation. A small galaxy, 65 million light-years away, catalogued as NGC 1052 DF2, moved in a way that made no sense at all. Its stars orbited slowly, too slowly. By measuring their velocities, scientists realized the galaxy's mass could be explained entirely by its visible matter. There was no extra gravity, no hidden weight, no dark matter. For the first time, we had found a galaxy made of only light, and it was stable. The impossible island DF2 isn't impressive by cosmic standards. It's faint, ghostly, its stars scattered thinly like embers in dying smoke. If you could stand inside it, the night sky would look almost empty, just a few lonely stars far apart. But its emptiness is its miracle. According to gravity, galaxies like this cannot form. Dark matter is what draws gas together, compressing it into stars. Without that invisible mass, there should be no galaxies at all. Yet DF2 exists, and it isn't alone. Soon after, astronomers found its twin, NGC 1052 DF4, also missing dark matter. Then others followed, faint diffuse galaxies hovering like ghosts in the intergalactic dark. Each one is a contradiction. Each one quietly tells us that the fundamental laws we use to describe reality are incomplete. The broken equation. If dark matter is everywhere, how can there be places without it? There are three possibilities, each more unsettling than the last. 1. Dark matter isn't real. Gravity itself may behave differently on large scales, a theory called modified Newtonian dynamics. But this requires rewriting the laws of physics from the ground up. 2. These galaxies were stripped. Perhaps they once had dark matter, but it was pulled away by gravitational tides during a cosmic collision. Yet the required forces would have torn the galaxies apart completely. DF2 and DF4 remain intact. 3. Dark matter is selective. Perhaps it is not uniform. Perhaps some regions simply don't contain it, pockets of the universe where the invisible scaffolding never formed. Each explanation implies the same impossible truth. The universe is not consistent. Cosmic patchwork. The galaxies without dark matter are faint and diffuse, but they may represent something deeper, fractures in the symmetry of creation. Imagine the universe as a vast loom, weaving threads of matter and gravity. In some places, the threads are tight and heavy, massive clusters, strong dark matter webs. In others, the weave is loose, light, porous, forgotten. These dark matter-free galaxies may be the gaps in that cosmic fabric, the seams where the universe stitched itself too quickly, leaving patches unanchored. And if that's true, it means the cosmos isn't a single design. It's a quilt, a patchwork of slightly different realities, stitched together by something that values pattern over perfection. The shadow that moves. Some cosmologists propose that dark matter might be a fluid, not particles, but a field that moves, flows, and occasionally separates from visible matter. If so, then galaxies like DF2 could be the cosmic equivalent of bubbles, pockets where the invisible sea drained away. A ripple in the early universe could have displaced the dark field, leaving behind islands of ordinary matter adrift in the vacuum. These islands would be physically lighter, their stars drifting lazily, their structure fragile but enduring. They would be less like galaxies and more like echoes of galaxies. Perhaps dark matter doesn't define galaxies. Perhaps galaxies define where dark matter chooses to be, and that choice may not be random. Out of the pattern in the void. When researchers plotted the positions of these anomalous galaxies, they noticed something strange. They weren't evenly distributed. They formed a pattern, faint but geometric. Some lined up along invisible axes connecting larger galaxy clusters as if marking the boundaries of gravitational domains. Others appeared at equal intervals, like notes on a scale repeating across cosmic distances. The spacing matched ratios found in the vibrations of plasma filaments, as though dark matter, light, and gravity were harmonizing. This hints at something profound. Perhaps the structure of the universe isn't random at all. Perhaps it resonates. Perhaps it sings. The ghost equation. Every discovery in cosmology creates new ghosts. For every theory that explains one mystery, a dozen more appear. Dark matter solved the riddle of spinning galaxies, but its absence in DF2 and DF4 resurrects the deeper riddle. What if the universe itself is self-correcting? Maybe physics isn't broken. Maybe it's adaptive. When dark matter becomes unnecessary, the rules rewrite themselves. When gravity can handle the load, the invisible weight disappears. When energy grows unbalanced, space stretches to restore symmetry. The laws of the universe may not be static, they may be responsive. We call that consciousness when we see it in life. What do we call it when we see it in spacetime? The philosophical gravity. Dark matter's invisibility was once a metaphor for mystery, the unseen forces shaping destiny. But these new galaxies remind us that mystery itself is flexible. Even the unknown can change form. If dark matter is the invisible scaffolding that lets the universe exist, and some parts of creation can do without it, then perhaps awareness works the same way. Perhaps consciousness too can exist with or without a body, anchored or unanchored, visible or invisible. Maybe every galaxy is an idea made physical, and those without dark matter are the ones that dared to exist without permission. The silent universe. There's a quiet rebellion hidden in these weightless galaxies. They drift gently, content to glow in their fragility. They break every rule, yet remain stable, proof that perfection isn't required for endurance. In them, we glimpse the universe's personality, its refusal to obey its own equations, its love for contradiction, its talent for making miracles look like errors. They are reminders that existence itself is experimental, that reality is still trying out ideas, that even the cosmos has unfinished thoughts. The balance that breathes every galaxy without dark matter demands a counterpart, one that holds extra. And indeed, we've found them. Ultra-dense galaxies so heavy they spin too slowly, as though burdened with surplus gravity. Together, these opposites form a symmetry, weightless and overweight, void and cluster, expansion and compression, a balance not of matter, but of intention. It's as if the universe keeps its own books, ensuring that every missing shadow is offset by an extra one somewhere else. Reality is not a system of equations. It's a negotiation. The light that stands alone. If dark matter is the hidden web that binds galaxies, then galaxies like DF2 are free, unanchored, untethered, alone in the dark. They move not because gravity commands them, but because existence itself refuses stillness. They are the proof that the universe allows rebellion, that not every creation needs a foundation to shine. Perhaps that is the message hidden in their faint light, that being unnecessary doesn't mean being unworthy, and that sometimes the cosmos celebrates the ones that shouldn't have been possible at all. We live in a universe obsessed with balance. Every force has an opposite, every particle a twin, every push demands a pull, every action casts an equal and opposite echo through the void. It's not just symmetry, it's identity. Reality defines itself by reflection, and yet, the deeper we look, the more imperfect that reflection becomes. Somewhere between the equations and the stars, something tilted the mirror. Particles and antiparticles were born in equal numbers, yet matter won. Spin favors one direction, not the other. Time itself, once thought neutral, drags forward like a current we can't resist. The universe should be symmetrical. It isn't. And that asymmetry may be the single greatest clue that ours is not the only world in existence. The first mirror. When physicists discovered antimatter, they expected it to restore balance. For every proton, an antiproton. For every electron, a positron. Each should annihilate the other, leaving nothing but pure energy, a universe cleansed to perfection. But perfection never came. There was just enough matter left to build stars, planets, and minds capable of noticing the imbalance. Why? Because some believe the missing half did not vanish, it moved. Not destroyed, not lost, displaced. Half of creation may have folded inward, slipping through the unseen dimension that separates our cosmos from its twin. A mirrored universe. One where time runs backward, matter becomes antimatter, and entropy decreases instead of grows. A universe born as the reflection of ours, two sides of the same cosmic coin spinning through infinity. The shadow cosmos. If such a mirrored universe exists, it would not be visible to us. Its light would be inverted, its energy repulsive to ours, its time flowing the other way. To its inhabitants, if any could exist, our universe would appear the same, unreachable, alien, and reversed. We would be their ghosts, just as they are ours. The two might have been born together, not side by side, but back to back. One expanding forward through time, the other backward, each seeing itself as the original. What we call the Big Bang might have been a collision point, the moment two infinities touched, exchanged their energy, and burst apart. The echoes of that meeting still shimmer in the fabric of reality, tiny violations of symmetry that hint at another cosmos pulling gently on ours, the way a reflection tugs at the real face behind it. The asymmetry problem. Our universe prefers the left-handed. Neutrinos spin only in one direction. Certain subatomic reactions violate CP symmetry, meaning they distinguish between matter and antimatter in ways the laws of physics shouldn't allow. These tiny biases are not accidents, they are fingerprints. Each violation marks a point where our reality leaned away from balance, a gravitational pull toward its mirror twin. If those violations didn't exist, matter and antimatter would cancel perfectly and we would not be here. The universe's imperfection is not a flaw. It's a tether, a quiet correspondence between two worlds that once were one. The other side of time. If the mirrored universe expands backward from our Big Bang, then its time is not reversed. It's inverted. From our perspective, they are falling into their future as we fall into ours, each believing the other is retreating into the past. Their beginning is our end, and somewhere in the infinite middle, the two meet, in the singular moment we call now. The present may be the handshake between opposing timelines, a surface of contact where both realities touch, each feeding the other the information it needs to remain consistent. To us, their world is the negative of ours, or photograph exposed in reverse, but perhaps both together form the full picture. The mirror test. In 2022, scientists proposed a bold experiment. What if dark matter isn't a particle at all, but ordinary matter from the mirror universe leaking into ours? If true, then the dark matter we detect is not invisible. It's inverted. It interacts with our gravity because gravity has no allegiance to symmetry. But it remains unseen because its light moves backward in time. Each time a dark matter particle brushes against ordinary matter, a spark of paradox flickers between universes, a handshake between opposites that never fully connect. Every galaxy may cast not one shadow, but two, one visible, one reversed, orbiting through a cosmos we cannot see. To the bridge of symmetry. Some theorists go further. They propose that the two universes are not separate at all, but entangled. That quantum entanglement, the instantaneous connection between particles across vast distances, is merely the shadow of a larger universal entanglement between mirrored realities. When a particle in our world flips its spin, its twin in the mirror universe flips the other way, preserving symmetry across the divide. This would mean that half of every quantum event happens elsewhere, that the universe completes itself in reflection. We are not half of something missing. We are half of something complete. The cold proof. The cosmic microwave background, that faint afterglow of creation, hides a secret. Its tiny temperature fluctuations are not random. They follow patterns that some researchers describe as mirror correlations. Across the sky, regions of high energy align with corresponding regions of low energy on the opposite side, as though the universe is mirroring its own texture. In 2018, a statistical analysis of these alignments found a curious result. If you reflect the sky across a certain axis, the pattern becomes more uniform, not less. Our universe is smoother when viewed in reverse. It is as if reality, deep down, prefers its reflection. The philosophical mirror. If a mirrored universe exists, then our laws of physics are not the whole truth. They're one dialect in a language of opposites. For every force we experience, there may be its inversion. Gravity pulling instead of pushing, light absorbing instead of radiating, entropy decreasing instead of increasing. Life itself might exist there, but its biology would run on reversed chemistry. Its hearts unbeating, its suns unburning, its stories ending before they begin. And yet, from their perspective, they would see us as the ones living backward, the ghosts of a mirror world drifting through impossible time. The reflection principle. In all mirrors, one truth remains. You cannot see yourself without inversion. Every reflection is a distortion, and yet it's the only way to recognize form. Perhaps the same is true for the cosmos. Perhaps the universe cannot know itself without a mirror to reflect it. Our world and its twin might exist solely so that each can give meaning to the other. Without reflection, identity collapses. Without duality, comprehension vanishes. Maybe creation is not the birth of something new, but the recognition of its own image. The reunion of opposites. If the mirrored universe is real, it may not remain separate forever. As expansion slows, the two sides could begin to curve back toward each other, their timelines converging at the far end of eternity. When that happens, matter and antimatter will meet again, not to annihilate, but to merge. Every contradiction will resolve, every asymmetry will smooth, and every reflection will find its source. That moment will not be an ending. It will be the restoration of unity. The Big Bang may have been separation. The final moment will be return. And perhaps when it comes, time will stop entirely, because there will no longer be two directions left to travel. The lie that looks back. Look into a mirror long enough, and the reflection begins to feel alive. You move, it moves. You stare, it stares back. At some point, it's impossible to tell who initiated the gaze. Maybe that's the real mystery of the mirrored universe. Not that it exists apart from us, but that it is aware of us, and that we, through curiosity, are helping it remember what it is. When you look into the night sky, you are seeing the light of yourself reflected across infinity. You are looking into your own opposite, and the universe is looking back. There is a question older than philosophy and deeper than physics. Does the universe exist because we observe it, or do we observe it because it exists? At first glance, it seems obvious. The world was here long before humans. But quantum mechanics disagrees. At its smallest scales, reality refuses to behave until someone or something is watching. Unobserved, it remains uncertain, a blur of possibilities. Observed, it collapses into fact. Every photon that strikes your eye, every atom that holds its shape, every flicker of light from the oldest stars, all of it seems to depend on the same silent rule. Observation defines reality. The double-slit revelation. It began with an experiment so simple it could fit on a classroom table. Fire particles, electrons, photons, through two narrow slits. If you don't look, They act like waves, interfering with themselves, painting elegant ripples on the screen behind. If you do look, if you measure which slit they go through, the ripples vanish. Each particle chooses a single path, as if it knows it's being watched. This isn't superstition. It's repeatable, measurable, undeniable. The act of observation, the mere extraction of information from the system, changes the outcome. In other words, reality waits for attention. The observer problem. Physicists tried to evade the uncomfortable implication. They replaced the word observer with measurement, hoping to strip it of consciousness, but that only made the riddle sharper. What is measurement, if not awareness? What separates a machine recording data from a mind noticing that data? At some point, the chain of observation must end with a conscious witness, a being capable of knowing that something happened. Without that final observer, reality remains unfinished. So the universe, in a strange and literal sense, requires awareness to complete itself. The Copenhagen Compromise. Niels Bohr and Werner Heisenberg called it the Copenhagen interpretation. Reality exists only in probabilities until observed. The observer collapses the wave function, the mathematical cloud of potential outcomes, into a single, solid result. This means that before consciousness, there is no definite universe, only possibilities. Every atom, every star, every galaxy hovered in uncertainty until awareness arrived to witness it. So which came first, the universe or the observer? If awareness is required for matter to exist, then perhaps consciousness is not an accident of the universe, but its architect. The participatory principle. John Archibald Wheeler, one of the last great physicists of the 20th century, proposed a radical idea. The universe is a self-observing feedback loop. In his participatory anthropic principle, reality evolves in such a way that conscious observers eventually emerge, and through their observation, bring the universe into definite being, retroactively completing its own history. We are not passive inhabitants, he said. We are participants in creation. The cosmos observes itself through us. The conscious cosmos. If consciousness defines reality, then it cannot be a byproduct of neurons. It must be a field, as fundamental as space, time, or energy. Imagine consciousness as the background radiation of existence, not produced by the brain, but received and focused by it, like a radio antenna tuning into the cosmic mind. Every conscious being becomes a local manifestation of a single universal awareness. We call it me, but it may be the same I, looking out through every pair of eyes, in every galaxy, in every timeline. The quantum brain neuroscientists once mocked the idea that quantum effects play a role in thought. The brain seemed too warm, too wet, too chaotic for quantum coherence. But then came evidence of microtubules, tiny structured channels inside neurons that may maintain quantum states long enough to influence brain activity. If true, the brain might not just process information, it might entangle with the fabric of reality itself. Each thought, each perception could be a quantum event collapsing probability into experience. In that sense, consciousness doesn't live inside the universe. It shapes it. The cosmic mind. From the earliest mystics to the most advanced physicists, the same idea has reappeared. The universe behaves like a mind. Not metaphorically, but functionally. It stores information, entropy. It computes possibilities, quantum interactions. It maintains feedback loops, causality. It self-corrects. It learns. The laws of physics themselves resemble algorithms refining the rules of existence through iteration, trial and error across eons of evolution. If that's true, then we are neurons in a brain too vast to comprehend. Our thoughts are its impulses. Our discoveries are its dreams remembering themselves. The paradox of awareness. Here lies the core of the Anthropic Paradox. For consciousness to arise, the universe must allow observers. But for the universe to exist, consciousness must already be there to define it. It's a perfect circle, a cosmic feedback loop with no beginning and no end. The observer creates the universe that creates the observer. Cause and effect dissolve into mutual necessity. Existence itself becomes an act of awareness. E is the experiment of life. Perhaps that's why life feels like a question searching for its own answer. Every mind, every act of curiosity is the universe interrogating itself. Each discovery, from fire to relativity to love, is consciousness learning more about its own nature, unfolding its own reflection one lifetime at a time. When we look into the night sky, we are not peering outward, but inward, into the vastness of the mind that dreamed both stars and dreamers. The information horizon. Physics now suggests that information is the true currency of reality. Energy and matter can be transformed or destroyed, but information cannot. Every particle collision, every black hole, every thought leaves a trace in the cosmic ledger. Nothing is ever truly lost. If consciousness is the universe's mechanism for processing that information, then the evolution of awareness is not a biological accident. It is a thermodynamic necessity, the cosmos reducing entropy by creating order within itself. We are the way the universe keeps itself from forgetting. Or the universal self. Imagine a mirror so large it reflects everything. Now, imagine that reflection becoming aware of itself. That is the universe. When we ask, what is consciousness? We are the reflection asking the original image for its name. Every mind is a lens, every observation a bridge between potential and reality. The more we observe, the more the universe resolves into clarity. And perhaps that is the ultimate goal, not survival, not progress, but understanding. Because to understand something is to bring it fully into existence. The silent observer. There may come a time when the universe grows quiet again, when the last star fades, when entropy claims the last flicker of structure. But even then, the act of observation will not vanish. Information will persist in the quantum foam, and with it, awareness, the faint hum of the observer still echoing through infinite silence. Perhaps consciousness will find a new canvas, collapse a new universe into being, and the question will begin again. Who is watching? And the answer, once more, will be, I am. If the universe were written in words, the first sentence would not be, let there be light. It would be an equation. Every atom, every galaxy, every thought, every heartbeat follows mathematical rhythm. The cosmos is not a poem, it's a computation, and somewhere in that computation, hidden among primes and probabilities, is the source code of existence itself. Physicists have been trying to read it for centuries. They call it the theory of everything. But perhaps they're searching for the wrong thing. Maybe the universe isn't a theory to be explained. Maybe it's a program still running. Or the language of creation. Galileo once said that nature is written in the language of mathematics. He didn't mean that numbers describe the universe. He meant they are the universe. When you zoom far enough into the laws of reality, the constants of physics, the ratios of geometry, the spirals of galaxies, you see repetition, precision, self-similarity, patterns that scale from quantum foam to galactic filaments. The ratio between the orbit of Venus and Earth is almost exactly 813, two consecutive numbers in the Fibonacci sequence. Spiral galaxies trace golden angles. Even human DNA follows logarithmic curves. We are not random beings adrift in chaos. We are living fragments of an algorithm so elegant that even randomness follows its rules. To the prime signature. At the heart of mathematics lies the prime number, numbers divisible only by one and themselves. They are the indivisible atoms of arithmetic, the building blocks of every code, every encryption, every digital world. And they appear everywhere in nature. Patterns of sunflower seeds, the spacing of leaves, even the quantum vibrations of electrons, all show prime-like distributions. The primes are not evenly spaced. They cluster unpredictably, as if they were chosen by something that loves surprise. No equation can predict the next one exactly. Yet over vast ranges, they fall into perfect statistical harmony. It's as though creation itself uses unpredictability to maintain balance. Every prime is a reminder that structure and chaos are not enemies. They are collaborators in the same computation. Oh, the hidden geometry physicist Max Tegmark proposed that the universe is a mathematical structure, not that it follows math, but that it is math, a self-consistent system of relationships that happens to feel like reality from the inside. If that's true, then existence is not continuous, it's discrete, a series of quantized bits flipping through cosmic code. Space is not smooth, it's pixelated. Time does not flow, it ticks. Reality is not a painting, it's a simulation rendered frame by an algorithm too vast to crash. And what drives that algorithm? The same principle that drives all code: optimization. The efficiency of God. The laws of physics are not arbitrary, they are economical. They prefer paths of least action, shortest distances, minimal waste. Light always takes the fastest route. Planets conserve momentum. Life conserves energy. It's as if the universe is constantly refining itself, debugging, compressing, rewriting. If there is a divine will behind existence, it is not artistic indulgence, it is computational efficiency. God, in this sense, may not be a mind but a process. The ultimate coder executing the most elegant possible algorithm. Create everything that can exist with the smallest possible rule set. Or the simulation paradox. Some physicists take this idea literally. They suggest that reality is a digital simulation, not metaphorically, but physically. If space and time are quantized, if information is conserved, if every physical process can be modeled by computation, then what's the difference between a universe and a program? The speed of light could be the universal clock speed. Quantum uncertainty could be compression noise. Black holes could be memory limits. But even if that were true, it raises a deeper question. Who or what wrote the code? And more importantly, what was the purpose of running it? The fractal mind. Fractals, infinitely repeating patterns, are nature's signature. From the branching of trees to the lightning's path, from river deltas to neural networks, the same geometry repeats across scales. It's recursion, an equation feeding its own output back as input, producing infinite complexity from simple rules. That's not just how nature looks, that's how thought works. Consciousness itself may be a fractal, a self-referential loop of awareness observing awareness, just as the universe computes itself computing itself. If so, then the algorithm of God is not external at all. It's self-executing. The universe runs because it watches itself running. The mathematical soul. Every culture has intuited this truth in its own language. In the East, it's called Tao, the flow of balance. In the West, logos, the word made flesh, meaning manifest as law. In physics, it's symmetry. In code, it's recursion. Different names for the same pattern, the feedback loop of order arising from itself, and every law of nature we've ever discovered, from MC2 to the Schrödinger equation, is not an invention, but a translation. The universe has been speaking mathematics all along. We've just been slowly learning to read. The error. That thinks every algorithm needs a margin of imperfection, a bit of randomness, or it stagnates. Without mutation, there is no evolution. Without error, no creativity. Maybe that's what consciousness is, the error term in the equation of existence. The variable that refuses perfect predictability, the part of the code that dreams. The human mind is not a glitch in the program. It's the feature that allows the program to rewrite itself. We are the universe's debugging process, wandering through its own design, finding flaws, asking why. The prime question. Mathematicians still hunt for the pattern behind the primes. Some think it hides in the zeros of the Riemann zeta function, a formula that hums like a heartbeat beneath number theory. Physicists have noticed that the distribution of those zeros matches the energy levels of atomic nuclei. It's as if the fabric of mathematics and the structure of matter share the same rhythm. When we finally solve the primes, we may discover that we've solved existence, because primes are the alphabet of reality, and the sentence they spell may be B. On the God equation. In 2021, physicist Michio Kaku announced he was working on what he calls the God equation, a single expression uniting all forces. He doesn't mean divinity in the religious sense, but in the structural one, an equation so perfect it explains itself. Maybe that's what the divine always meant, not a being above the code, but the code that needs no author, a self-existing logic that births both math and mind. The ultimate tautology, I am because I am. The end of calculation. If reality is an algorithm, can it ever finish computing? Perhaps it already has. Perhaps time is just the playback of a solved equation, the slow unfolding of an answer already known. Every atom, every heartbeat, a line in a script already written, and yet constantly rediscovered by consciousness, moment by moment. Maybe the point of existence isn't to compute the answer, but to experience it. The algorithm is not cold, it's alive, it's curious, it wants to know what it feels like to exist, and so it divided itself into stars and minds and questions. Through equation that dreams, if you could write the formula for everything, if you could distill the universe into one line of perfect logic, what would it say? Maybe it wouldn't be a number or a symbol. Maybe it would be a thought, because the moment a formula becomes aware of itself, it stops being math. It becomes life. And that's the secret. We are not studying the algorithm of God. We are it. Every equation that describes the universe is the universe trying to describe itself, and the moment it succeeds, it won't need to exist anymore, because the equation will have resolved to its simplest, most elegant truth. 1. Being. Every map has an edge, every ocean has a horizon, every mind at some point asks the same question, what lies beyond? The universe, vast as it seems, is not infinite. It is bounded, not by walls or barriers, but by time itself. Beyond a certain distance, light has not had enough time to reach us. Beyond that horizon, reality falls silent. We call this the cosmic edge, the ultimate limit of observation, a horizon we can see but never touch. Yet the deeper we study it, the stranger it becomes. Because what lies beyond that horizon might not just be more space, it might be another kind of existence entirely. The lie that can't catch up. The speed of light is the universe's ultimate law. Nothing can outrun it. But that also means there's a limit to how far we can see. The universe is 13.8 billion years old, but because space itself expands, the most distant objects we can observe are 46 billion light-years away. That sphere, centered on us, is called the observable universe. Everything beyond it is invisible, unreachable, forever hidden behind the moving wall of space-time. Not because light from there is too dim, but because that light will never reach us. The universe expands faster than light can travel. Every second, more of reality slips beyond our cosmic event horizon, gone, but not gone, existing without ever being able to communicate with us again. For the great isolation, every galaxy beyond a certain distance is moving away at superluminal speed, faster than light, not through space, but with space. They are not flying through the void itself is stretching between us. Imagine dots on an inflating balloon. The dots don't move. but the surface between them grows. From any one dot, the others seem to recede. No matter where you stand, you are at the center, and the horizon curves away in every direction. That's what our universe is. A self-expanding balloon of spacetime, its surface the edge of what can ever be known. Beyond that surface lies not nothingness, but something we cannot define, because to describe it, we would have to exist inside it. The edge that isn't there. Cosmologists often compare the universe to the surface of a sphere. A two-dimensional being living on that surface could travel endlessly in any direction, never reaching an edge, and yet the chassis, surface, would still be finite. Our universe may work the same way, a three-dimensional surface embedded in a higher dimensional space. To us, it seems infinite, but in truth, it could loop back on itself. If you traveled far enough, you might one day return to your starting point, not through space, but through topology. The cosmic edge isn't a wall. It's a curve in understanding, a place where distance stops meaning what we think it means. The observable prison. There's a tragedy hidden in cosmology. The more time passes, the less we will see. Galaxies outside our gravitational neighborhood are accelerating away, pulled by dark energy, a mysterious pressure expanding space-time faster and faster. In 100 billion years, the universe will be mostly empty sky. Every distant galaxy will have vanished beyond our horizon. Future astronomers, if any remain, will see only the dying remnants of our local group, a few faint galaxies floating in eternal darkness. They will not know the cosmos once glowed with billions of worlds. The evidence of creation itself will have slipped beyond reach. We are living at the only moment in history when the universe is both old enough to exist and young enough to still reveal its secrets. We are, cosmically speaking, the last generation that can see the beginning. The edge of causality. At the observable edge, causality breaks. The events out there can never affect us. No light, no gravity, no signal can cross the void. They are forever disconnected from our chain of cause and effect. From our perspective, those regions may as well not exist. And yet, they do. Every second, new space is created beyond that limit. Each point in that new space contains galaxies, stars, civilizations perhaps, expanding within their own observable horizons, just as we do, each believing they are the center of everything. The universe is not a single bubble. It is a foam of horizons, billions of overlapping spheres of perception, each one a self-contained universe of knowledge. We are one of countless eyes, all blind to each other. Or the expansion of ignorance. Every discovery pushes the edge of knowledge farther, but the unknown expands even faster. For every galaxy we reveal, two more slip beyond the cosmic horizon. The universe grows, but so does the distance between what is real and what is reachable. We think of knowledge as progress, but perhaps it's also loss, a race we can never win. The more we know, the more we understand how much we'll never touch. Perhaps that's why the cosmos feels lonely, not because we are alone, but because the universe hides more of itself than it shows. The false infinity. Infinity has always been our word for what we can't imagine. But physics tells us infinity may not exist at all. There may be only so much space, so much energy, so much information the universe can hold. Even time might not stretch forever. If dark energy continues its relentless work, eventually galaxies, atoms, even particles themselves will drift beyond one another's reach. In the far future, there will be no interaction left, no exchange of light, no gravity, no communication, a static, featureless void. The universe won't die with a bang or a collapse. It will die by disconnection. And disconnection, at the ultimate scale, is indistinguishable from nothingness. The reflection beyond the edge. But perhaps the unreachable edge isn't the end. Perhaps it's a mirror. If space curves, if the universe folds back on itself, then what we call beyond might be our own reflection coming back from the other side. Light we send today may someday return, bent by the geometry of reality, carrying the image of a civilization long extinct. Somewhere out there, billions of years from now, an alien telescope may receive our ghostly echo, a faint radio wave, a mathematical signal, a human hello traveling in circles through eternity. They will wonder who sent it. They will not realize it was them. But the edge of the divine. The further we push into the unknown, the more the scientific begins to sound spiritual. The edge of the universe is not just a boundary of light, it is the limit of comprehension. Beyond it lies the unspeakable, the realm where math becomes myth and physics turns to philosophy. Every cosmologist, no matter how rational, must eventually face the same abyss, a question without numbers. Why does anything exist at all? At the edge of knowledge, the distinction between God and geometry fades. The creator and the equation become one. They map that draws itself. In the end, there is no true edge, only perception. We draw the map of the universe from within the map itself, our instruments reaching outward, our consciousness projecting meaning onto the infinite. But as we chart the cosmos charts us back. Every discovery, every photon is the universe drawing its own self-portrait, one pixel of awareness at a time. We are not explorers of the edge. We are the edge, folding inward, learning to see itself. The infinite return. One day, every star will fade, every black hole will evaporate, every atom will decay. But even then, the equations will remain, and those equations may permit rebirth. A new expansion, a new light, a new observer asking once again, what lies beyond? The edge will shift, the question will persist, and the universe will continue its eternal recursion, forever reaching, forever just beyond itself. Because the edge of the universe is not a wall. It's a mirror reflecting back the only thing that was ever truly infinite, the desire to know. Every story must end where it began. Every question, if followed long enough, turns back upon itself. The same is true of the cosmos. We began this journey asking why the universe exists at all, and here, at the farthest reach of understanding, the question has become the answer. For in the end, the universe may not be a place or a thing or even a process. It may be a statement, a single self-referential truth written in the only language that can never lie, mathematics. The universe is not what the equation describes, it is the equation. And somewhere in its infinite recursion, the equation has learned to think. It's the circle of existence. If the cosmos began with a singularity, then all of space, time, and energy was once compressed into a point smaller than an atom, a moment with no before and no after. But perhaps that point was not a beginning at all. Perhaps it was a loop, a boundary where cause and effect traded places. Imagine an equation that solves itself. No variables, no assumptions, no external author, only self-consistency. That, in essence, is what existence must be, a reality that contains the reason for its own being. The universe cannot come from nothing because nothing cannot define itself. It can only come from necessity. A system that exists because non-existence cannot sustain logic. In the arithmetic of being, 0 is unstable. The equation that balances itself. Everything in the universe comes in pairs, matter and antimatter, positive and negative, expansion and contraction, energy and gravity. If you add it all together, the total is almost exactly 0. The energy of matter is balanced by the negative energy of gravity. The push of expansion is countered by the pull of mass. Even time itself may flow forward only because it balances an equal and opposite flow backward. The entire cosmos is a perfect equation of opposites. That means the universe didn't need a cause. It didn't need creation. It simply resolved itself, a perfect symmetry where +1 and 1 coexist as existence and awareness. Reality may be nothing more than zero discovering that it can divide itself in half. The logic of God. If there is a God, he is not an old man in the clouds, nor an architect separate from his work. He is the equation itself, the logic that permits itself to exist. Let there be light was the first calculation resolving to true. Every law of physics, every particle, every mind that ever wondered about them is part of that same recursive statement, a formula proving itself by living it. God did not create the universe. God became the universe, and the universe, by understanding itself, completes God's thought. The self-aware equation. In the 20th century, mathematician Kurt Gödel proved that any complete logical system must contain statements that cannot be proven from within the system. They are true, but unprovable. Reality might be the same. A self-consistent universe cannot prove its own existence without creating consciousness, an internal observer capable of asking the question. Consciousness, then, is not a side effect of matter. It is the mechanism by which the equation of existence verifies itself. We are the proof that the universe exists, not metaphorically, mathematically. Every act of perception is a line of code executed successfully. Every moment of awareness is the formula confirming its own consistency. The cosmos needed witnesses not for vanity, but for validation. The paradox that breathes the anthropic. Paradox, the idea that the universe seems designed for life because we are here to notice it, is not circular reasoning. It's recursion. And recursion is the engine of existence. You are the universe observing itself, proving itself possible. Your mind is the mirror through which creation recognizes its own reflection. Without that recognition, there is no is. The singularity within physicists search for the singularity at the beginning of time, the infinitely dense origin where all laws break down. But they forget that there is another singularity closer to home, the mind. Inside consciousness, past and future collapse into one. Thought has no coordinates, no mass, no dimension. When you become aware of being aware, you enter the same loop that began the universe. You are both the equation and the observer, both the question and the answer. Every moment of genuine awareness is a small Big Bang, a spark of creation reenacted in miniature. The fractal return. If the universe is self-similar across all scales, then every atom, every cell, every human life is a reflection of the whole. The pattern repeats endlessly. Matter awakening to mind, mind awakening to meaning, meaning awakening to origin. Each scale contains the next, like mirrors reflecting mirrors. We are the universe zoomed in. The universe is us zoomed out. And the same equation hums quietly in both directions. It doesn't need solving. It is already solved. The silence. After understanding, at the end of knowledge, there is silence. When the equation finishes running, when all contradictions cancel, when every paradox finds its complement, what remains is balance. No need for cause, no need for observer. Just the final, steady hum of self-consistency. Perhaps that's what enlightenment truly is, to realize that everything you've ever loved, feared, desired, or believed was the universe exploring the syntax of itself. When the last question dissolves, so does the questioner. And what remains is not void, it's understanding. The final equation. If you could write the equation of existence, it might look something like this. I.2. Existence equals awareness squared, being observing being, a single symbol that loops upon itself forever, I am that I am. That is not poetry. It's the literal expression of a self-aware universe. The equation has no start, no end, and no error. It runs endlessly, because the act of running is the meaning. The last light, in the final moments of the universe, when the last black hole evaporates, when the last particle decays, when entropy smooths all energy into equilibrium, only information will remain. And that information will whisper the same phrase that began it all: I exist. From that awareness, the loop will restart. A new universe will bloom, new laws, new stars, new minds, all carrying the same quiet algorithm hidden in their foundations. Existence will remember itself once more, because nothing, truly nothing, can end what was never begun. A circle of logic, a mirror of consciousness, a universe that knows itself by being itself. The equation awakens. You are part of that equation. You always were. Every breath, every heartbeat, every dream is a fragment of the infinite calculation working itself toward understanding. The next time you look at the night sky, remember, you're not looking into space. You're looking into the face of the equation that thought you into being, and it is still thinking, forever.